Welcome to Talking Tech. I'm your host, Marcus Yam, and today we're diving into 13th gen Intel Core processors, codenamed Raptor Lake. Now, we launched those unlocked desktop processors back earlier in the fall, and they are fast and furious. And today, we're here to talk about family. Joining me is Dan Rogers, Senior Director of the Mobile Performance Lab at Intel. Dan, thanks for joining.
Thanks, Marcus. Great to be here.
So, can you give me a bit of a recap of what we have to share today, and also how we got here?
Yeah, not only is our processor fast, but we've been on a torrid pace here, releasing our hybrid architecture. Starting with Alder Lake last year, updating with our HX processors, and moving to the second chapter of performance hybrid with Raptor Lake just a few months ago. And today we're here to expand the family to announce 15 new desktop SKUs as well as our entire mobile lineup.
So going back, can you just recap how has the reception been? How has the launch of 13th Gen Raptor Lake met your expectations so far in this kind of enthusiast K-unlocked overclocking space?
Yeah, I think it's safe to say that our hybrid architecture that we started in Alder Lake has really moved us in a different direction in client. Most recently with our desktop processors, we've seen the fastest K-SKU ramp to date that we've ever had, 40% faster than even our 12th gen K-SKU processors. So we're super excited about that and hope to carry that momentum now into 2023.
What are some of the highlights? You talk about similarities, there's like the performance hybrid architecture, but what are some of the highlights in terms of that jump from 12 to 13th gen?
Well, our hybrid architecture started with the concept of having two different types of cores, one type optimized for top-end performance and frequency, and another type of core, what we call our efficient cores, added for scalability and thread density. And now we're taking that to the next step, making an even faster core with Raptor Cove, new with Raptor Lake 13th generation, and scaling out our efficient cores up to 16 cores and 24 cores total in our Raptor Lake family.
You talked about Raptor Cove, so can you tell me what are some of the new generational improvements from in Raptor Cove?
Yeah, so Raptor Cove is really built for speed. We did a lot of speed path work and worked as an integrated company with our process technology to deliver the fastest possible frequencies on a single core. 5.8 in desktop, even faster frequencies coming soon, and 5.6 in mobile. And
just for those who don't know, when you refer to Raptor Cove, that is the performance cores in this performance hybrid. Let's talk about the E-cores, the efficient cores then. Is there anything new there?
So the efficient cores in Raptor Lake are, of course, faster, reaching the same frequency as our initial Skylake cores on 14 nanometer, so delivering that same Skylake-like performance that we all know so well from the 14 nanometer days, but at significantly lower power. And this is of great top-end performance as well as efficient performance at power.
So I'd say that Alder Lake was proving out that performance hybrid architecture, and now this is expanding on Raptor Lake. So
yeah, this is the next chapter.
So can you tell me, with the decision between increasing those E-core counts, how does that play out through, I guess, the rest of the family?
Yep, so we tried to not only increase the top-end SKUs, our Core i9s, both on desktop and mobile, but scale up our core counts and thread densities across the entire SKU stack, all the way down to Core i3 and below. So you'll see richer core counts, richer core configurations, faster frequencies. That's what the Raptor Lake family is all about.
So just to put a number on it, that means you've doubled the E-core count from at least the Core i9 level from 8 E-cores now to 16. And obviously now for the expanded family, the Core i5s are a real benefactor on 13th gen because those also get E-cores. But what was the decision behind just putting that throughout the entire lineup?
Yeah, our Core i5 on desktop and on mobile, it's sort of an unsung hero. Core i9, of course, gets the spotlight because of its incredible top-end performance. But our Core i5 is in desktop is great for value builds. It increases the E-core core count for more multi-threaded performance, 30 to 40% faster than Alder Lake, and delivers an Alder Lake-like performance, but at half the power at 65 watts. So this really speaks to the capabilities of the architecture, delivering great performance gains gen on gen, as well as more efficient operation where compared to different power levels.
You mentioned 65 watt. That number sticks in my mind because at a presentation you gave at the Intel Technology Tour in Israel, you had this slide up comparing 12th gen i9 versus 13th gen. You showed that the 13th gen at 65 watt at the 3900K operated at a similar performance level as a 12900K. So that was pretty impressive. How does that 65 watt performance level, what does that mean for the new family that we're talking about today?
Yeah, so today we're introducing lower TDP processors, 65 watt and 35 watt. And these are geared towards lower power, lower cost builds, all-in-ones, commercial systems, to support really the whole range of PC desktop form factors that we have in the market. And this is a way that we can really take advantage of our hybrid architecture to deliver performance not just at 200 plus watts for the enthusiast community, but also to deliver performance at more reasonable power levels for folks seeking a different design point. Hybrid is great for both. And today we're building out our desktop lineup, announcing 15 new SKUs across these different lower power levels.
Now, you're talking about the expanded family here, but to kind of look at, are there any other improvements in the core technologies that we talked about in 12th gen, like Thread Director? How is that, at least on the desktop side? We'll get to mobile in a second, but how has Thread Director evolved from 12 to 13?
Sure. Well, the software never stops. So hardware moves forward, so does software. We have an enhanced Intel Thread Director, which we partnered with Microsoft to build in additional improvements to our algorithms. The new enhanced Thread Director has a better handling of background low quality of service tasks. So we can now differentiate from, for example, like a virus scan or a system task that's happening in the backgrounds, and you want to make sure it really doesn't interrupt the user flow. Whereas you may have like a minimized window or a render, some background activity that is actually performant. We'll now separate and distinguish between these two types of activities, making sure we give the best total user experience.
With 12th gen, we definitely led the charge on PCIe Gen 5, DDR5. Are there any updates on that for 13th gen?
Yep, 13th gen has a variety of platform updates. So this is our second generation DDR5 implementation, which is now faster. Our second generation LP5 implementation, which is now faster for mobile. And we've also updated our I/O. We have a new Bluetooth Low Energy, which is a huge revolution in Bluetooth technology. Not unlike Wi-Fi 6E last year, we've also updated the Bluetooth side this year. And we've also increased our Thunderbolt support on the I/O side, now supporting DP 2.1 and USB 3.2.
Of course, one great thing right now is that the sockets are pin compatible, and you're just able to upgrade from your Alder Lake to 13th with just a drop in the processor. Or of course, you have more choice in chipsets and motherboards because you can use a 600 series as well. So that's great news for someone who's really going after value. I guess what I want to know is what is the value equation? We talk so much about performance, but where is the value, or where do you see the sweet spot in value in this new lineup?
Yeah, it comes down to compatibility. Being able to reuse a 600 series motherboard that you may have had from your Alder Lake build. Obviously, that's a core component, but also supporting all the range of I/O and memory types, particularly DDR4, which is critical to hit certain cost points when you're doing a low cost or low power build.
Dan, do you have any other thoughts on desktop before we jump into what's new for mobile?
We're excited to bring these 15 new processors, increasing our range of TDP support now for the low power space, 65 watts and 35 watts. We think users will be impressed with the great performance and the continued compatibility space that we're bringing with Raptor Lake 13th generation.
So that was desktop, but we have a lot of news on mobile. So what's the news today on Raptor Lake for laptops?
Yeah, you can probably break out your eye chart, Marcus, and help us walk through the news letter by letter.
That's right. So last time we talked, which was HX on Alder Lake, I had an eye chart made with everything before HX. I had this eye chart made, and I know at Intel sometimes we joke that our presentations can look like eye charts. So I made this for the family, for S for desktop, H for mobile enthusiast, U and P for ultra mobile. So I was missing that X that you said you need to update. So I made a new one for Raptor Lake right there. Just test your vision. So yeah, let's go through the entire family as noted on this eye chart.
Yeah, well, thank you for that great visual description. So we're proud to announce our entire 13th generation lineup. So our S that we talked about on the desktop side, but also our HX Extreme Performance Edition for mobile, as well as the entire mobile family itself, H series, P series, and U series, all the way down to 15 watts.
Okay. Again, referencing the last time we talked about that eye chart was 6 months ago, and like I said, at that time, HX came after the rest of the family. And now it seems to be the headliner with this mobile launch. Why the change in order that we're leading with HX this time?
Sure. We introduced HX largely for our mobile workstation customers who needed extreme levels of I/O and memory. But we found through that process a huge demand for even more performance in mobile, and we wanted to start that way this year in 2023 at CES, bringing our Raptor Lake 13th generation HX processors to market.
One thing I do remember from HX, which was remarkable, was it was an adaptation of that S desktop chip, but in like a mobile form factor. Is that the same this time with a 1213?
Sure, it shares the same architectural heritage. It's the same core count, same fundamental core design, although we retarget and repackage. So we change the process technology to optimize for a little bit lower power operation, actually near Vmin at 45 watts and 55 watts. And then we repackage the processor into a BGA package versus the LGA that you have shown here. And that enables us to hit the sleek form factors in that 22, 20, 20, 19 millimeter size systems.
How does it compare to the HX systems from 12th gen?
It's actually compatible. It shares the same package, and that allowed us to go a lot faster this year to market. So we're starting this year with HX and scaling HX to over 60 notebook platforms in the first half of the year.
Now, where we're shooting this video is actually, in the next room is actually the lab. So we're going to take a look at some of those new 13th gen laptops, and I do want to see like what kind of systems can pack this much power in a pretty portable. In fact, wait. That's one of them right there.
Yeah, we have two here, one with our H series and another with our HX processor. And it's a real systems engineering challenge. Part of our role at Intel is not just to make the processor or the chip, but it's also to do the full system engineering with our partners to deliver the full experience for the user. We're passionate about packing more and more and more performance into the given form factor, and that's what we're doing this year with 13th gen.
So in that case, tell me like the jump. You know, we talked about performance, computational workloads, like just you kind of threw everything you had at HX on 12th gen. Can you summarize like what is this kitchen sink? What's in the kitchen sink? What's going along with the kitchen sink for HX on Raptor Lake?
Yeah, so we knew that this was a critical chip for the most intensive professional usages, like pro content creation in 3D or advanced engineering applications or developers. But through that process, we also learned that this is a great chip for gaming. So many of our gaming systems this year will adopt this HX technology, featuring up to 24 cores. It's our first 24-core laptop and 5.6 gigahertz maximum turbo specification. The performance is really mind-boggling. And not only that, but we've been able to fit it into a very sleek form factor.
Were there any technologies going to 13 that enabled these new form factors or these new designs?
Yeah, so part of it is our system engineering activities, but the big story in 13th generation is actually our Intel 7 3rd generation SuperFin process technology, where we've been able to take this very high performance architecture and optimize the VF curve to fit into a low power operation for notebooks.
Now, performance and power, these are usually things that kind of go hand in hand, and like, you know, how they work. So obviously, on desktop, you have a lot more thermal headroom. Can you talk about how you've managed, you know, power and performance on HX given the form factors that we have to work with?
Sure, thermal management is key, and for that at Intel we use our dynamic tuning technology, which monitors platform thermal parameters, like for example skin temperature, and we're able to dynamically adjust the amount of power that we give to the CPU all the way down to our P code to throttle or dynamically modulate how much power we're giving the processor to react to the actual system conditions.
What about the platform itself, right? We talk a lot about the processor. You know, laptops, this is especially important for platforms because there's a lot less flexibility, so you kind of have to, you know, take what you get, right? You have to choose wisely. Talk about the platform a little bit.
Well, it starts with platform engineering. We work with our partners as well as our third-party hardware vendors as well, GPU manufacturers, memory manufacturers. We try to bring that all together to deliver the best total experience within the given form factor. It's not easy to optimize all these various parameters. We've actually extended our dynamic tuning technology to support third-party graphics. And in this way, we can seek to optimize the best possible user experience, whether you're gaming or doing some lightweight productivity or watching a video.
And of course, you know, HX does retain this things for professionals. You mentioned a bunch of workloads, but mission critical, there's ECC memory as well support.
Yeah, we have the full complement of memory support up to 128 gigabyte, as well as ECC and even overclocking support for those who want to push the fastest possible speeds.
One other thing that people usually don't think of when it comes to, you know, mobile laptops, that sort of thing, is overclocking options. But HX has overclock options like unlocked pretty much from top to the bottom of the SKU. I mean, correct me if I'm wrong, but it sounds like that this is, if you want to overclock on mobile, you know, HX is what you want to go after.
Yeah, generally we think about overclocking in the desktop context, but if there's performance there, we want to unlock it. So we do that primarily for memory and mobile to allow our OEM partners to ship with overclocked faster memory above our specification. So this is very common. You'll see this through our XMP tool. But we also support core overclocking on all of our processors, from Core i5 to Core i9.
Okay, so there's clearly overclocking options on HX. In fact, people who want overclocking from desktop to mobile, could they think of the X and HX kind of like being the K on desktop?
Yeah, this is our extreme performance option. So the X is meant to represent the absolute best that the platform can deliver, both on memory and on the core.
All right, so talking about performance, we have to get to performance workloads. There are some, pretty big leaps in performance going from 1213 on the desktop. What does that look like on HX going from Alder Lake to Raptor Lake?
Yeah, well, performance-wise, we have 10% single-threaded performance and nearly 50% over our last generation HX 12900HX processors. And this is great for both gamers and creators. Gamers can, when paired with the latest GPUs, expect the fastest possible frame rates. And 2D creators, like folks working in 8K, or 3D creators, like video game developers, or even engineers working in the Autodesk suite, for example, can experience the maximum possible multi-threaded performance in their laptop devices this year.
So again, like clearly massive performance numbers, but what kind of engineering goes into making those numbers possible in this generation?
Well, it starts with the process, our 3rd generation SuperFin technology with Intel 7. And this process technology allows us to reach even faster frequencies on the P cores and on the E cores. We've paired that increase in frequency with additional cores, so we have more E cores, up to 24 cores in total. And finally, we've increased our cache sizes too, both the L2 and the L3. And the combination of these 3 factors gives an absolute best-in-class performance capability.
Can you talk a little bit more about this increase in cache? What does it actually do for performance? Why does the processor benefit so much from the increase in cache?
Yeah, for gaming, it's all about latency. So additional cache sizes with better algorithms allows lower latency, which increases your frame rates. It's really as simple as that. And this is really helpful too when you have faster cores. The combination of the two with latest GPUs delivers the best frame rates.
Let's talk about the platform as a whole as well. What about connectivity?
Our connectivity is also updated. Last year we talked about Wi-Fi 6E, which was a huge change for the industry and now really ramping at scale. This year we're introducing, for one of the first PCs ever, Bluetooth Low Energy Standard, or the Bluetooth LE audio standard. And this is really a revolution in Bluetooth, one of the biggest in probably a decade. And it introduces a new compression algorithm, LC3 codec. And this LC3 codec is actually lower power and much higher quality. It also introduces for the first time a true stereo wireless experience. So you get both that real, for audiophiles, you get that real left-right full experience like you would with the wire. And finally, it introduces an ultra high fidelity audio experience too. So this is great for streamers or people doing a video conference.
I want to bring back a question that I asked you last time we talked about HX. Is if someone wanted to go all out on a configuration on HX, what would be the memory configuration and storage configuration, and in terms of like overall bandwidth, like PCIe Gen 5? Like what is everything that you can put in an HX system?
Well, one of the hallmarks of HX is a huge amount of I/O and a wide storage capability. So we can support up to 4 SSDs. We can support up to 2 attached Thunderbolt ridges, discrete ridges, for muxing discrete graphics and connecting to really high quality Thunderbolt displays. And we can also support up to by 16 discrete graphics in the chassis. And this is an incredible amount of I/O for a notebook.
All right, so this is for like someone who wants absolutely everything, has an unlimited budget, but the great thing about PCs, even laptops, is that there's something for everyone. So we've talked a lot about HX, but of course, like on this eye chart, I'm going to bring it up again. There's more to the mobile lineup, right? There's H series, P, and U. Can you talk a little bit about what's new for those chips?
Sure. Our rest of the mobile lineup, as you mentioned, H series, P series, and U series down to 15 watts are all updated as well. And these feature faster clocks for more productivity performance and turbo performance, up to 10% better productivity than our 12th gen Alder Lake systems. And we've also improved our power. Our EVO specification is now updated to reflect a 30-minute battery life improvement, powered by the enhancements that we've made with our Raptor Lake processors.
What were the technological improvements that kind of paid off these gains that you've just been talking about?
Yeah, it's really 2 areas. While the core configuration is similar, we've enhanced our process. We have a better VF curve, so we get better frequency at power, or better operating in battery life use cases. And the second thing that we've really spent a lot of time in the last year is refining the architecture and our power management flows to deliver better real-world battery life as reflected in the EVO specification.
Now, I've actually seen one of these chips with H, P, and U, and they look similar, but at power they operate differently. So can you talk about how the relation between the processor-based power on those chips translate into like form factors, usages, that sort of thing?
In general, we talk about our enthusiast laptop product lines at 35 and 45 watts, but of course many will ship with even richer configurations to deliver the best-in-class performance. Our thin and light laptop processors generally ship at 28, 20, or 15 watts, and these are for more common 13-inch type form factors or even smaller, thinner notebooks that are really for on-the-go professionals, people that need to do emails, light productivity work, and web browsing. And that's a great choice when you want that top-end turbo bursty responsive performance, but in a thin and light form factor that has great battery life.
You mentioning battery life, you said on Evo, you're getting on the Evo systems, you're getting 30 minutes more as part of the specification. How did you achieve that? With there are some similarities between older and Raptor. Where did those extra battery and power efficiency gains come from?
Through that enhanced process, we're able to get better voltage and frequency, both at the top ends, but also at low power points too. And this translates to better real-world battery life. And the second thing we've done is working with our system engineers as well as our power management architects. We've been able to add some new power management features to better control power in low power envelopes. And this also helps to contribute to that update in the Evo specification.
There's also the updated DisplayPort 2.1. So just talk about that addition.
Sure. Our Thunderbolt technology already supports the best in terms of displays and storage support to external. But we've updated our technology set with Raptor Lake to support the latest DisplayPort 2.1 standard as well as the latest USB 3.2 standard, increasing bandwidth from 10 gig to 20 gig.
You're talking about bandwidth again, and I think one of the big things we did love about 12 and especially 13 now is PCIe Gen 5 support. That wasn't available on H for the 12th gen, but it is now on 13. So did something change in the industry that allowed Gen 5 to be supported on H for 13th gen?
Yeah, well, we were the first to introduce PCIe Gen 5 support, going all the way back to Alder Lake when we introduced the first desktop processors, which was really a revolution in leading the I/O transition. We've continued to see PCIe Gen 5 ramp slowly in the industry. Now we're taking that more pervasively to our lineup all the way down to mobile.
One other new kind of addition coming in is the Movidius VPU, which is something kind of, I think pretty unique in the mobile space. So, what is it and what does it do and why should people care?
Yeah, sure. Well, we've been working hand in hand with Microsoft, one of our core partners in our AI effort, to support their Studio Effects package. And as part of that development effort, we realized we wanted to get a jump on what future processors will bring. So this generation, we're introducing on select designs a discrete AI accelerator that'll help deliver those experiences and also give early adopters a chance to really get a hands-on experience ahead of future processor launches.
Will these enable like new usages or new features, or is it more of a let's accelerate kind of new things that are maybe currently done in software, maybe not efficiently, or it's running more, sucking more power than it needs to? Which is it? Is it new features, or is it accelerating existing workloads?
It's actually going to be great for both. So part of the benefits of having a discrete acceleration is that you can offload both your CPU and your GPU from that work to deliver a better quality of experience across the board. But you also get the opportunity to add new features, which is what through some of our software partners we're able to bring this year through these select systems.
Again, talking about software and hardware, are there any changes in the way Thread Director works on these mobile systems compared to like HX or S?
Thread Director is sort of dynamically tuned to the actual workflow as it's happening on your system. So that's sort of the magic of software. We're able to provide that richness of information about what's really running on the chip up to the operating system so that the operating system can make the right scheduling decision at the right time on the right core.
Now there are a lot of discrete graphics options that people can configure when they choose their HX system. But for a lot of the mobile systems, they're also getting really great graphics support through our Intel integrated graphics. So talk to me about some of the new improvements that people are getting in their IGPs.
We have a few new integrated graphics features this generation. First is a new feature we call Endurance Gaming. And Endurance Gaming is really a frame pacing feature that slows down the frame rate to maximize the battery life while you're gaming on the go. You could think about this for a thin and light user who wants to maximize their hours of playability and ensure a minimum quality while they're gaming. So this is the first feature called Endurance Gaming. The second feature we're bringing is actually bringing our XCSS technology, our AI upscaling, from our discrete graphics to our integrated graphics to deliver a net 30% faster frame rates with similar levels of quality in games that are enabled.
So we've unpacked a ton of news for what's new for Raptor Lake. Starting with the desktop, then of course the HX, which sounds like it's kind of your favorite, and of course the rest of the mobile family. Kind of any final thoughts, top to bottom?
Sure. Well, to summarize, we're adding 15 new desktop processors at 65 watts and 35 watts for small form factor builds and all-in-ones. And we're also introducing all 29 mobile processor SKUs for our highest performance HX series of processors, all the way down to our U series thin and light processors at 15 watts. And we're ramping as fast as we can. Our Raptor Lake family is largely compatible with our Alder Lake family, both in desktop and in mobile. And this allows us to go really fast in the market and deliver this great performance early in the year.
And talk about the number of systems people can expect.
We have over 60 HX-based systems coming to market in the first half, and over 250 mobile systems for U, P, and H.
Great. Well, like I said, we're just in the next room from the lab, so can't wait to take a look. But Dan, thanks for talking tech with me today.
Thanks, Marcus.
And I appreciate it.
Thank you.
Thank you.